of course, it was a webinar. We are not in Brussels, hopefully, that we are much more than we were expected to be in Brussels. So I'm going to talk about one of the parasites that we included in our project that was an emerging parasite, which is Enterospora nucleophila. So let's see first what's Enterospora nucleophila, because many of you don't know about this parasite. It's a microsporidian, so it's unicellular, it's an obligate parasite, but has the peculiar characteristic that it's not only inside the cell in the cytoplasm, but also inside the nucleus of the host cell. It has a direct transmission from fish to fish, and the spores are the resistant stage. This is a non-zoonotic parasite, so there are no health issues for humans consuming infected fish. And one of the problematics of studying this parasite is that the spores are very, very, very small. They don't even reach 2 microns. And thus far, we have studied this in gillhead cyprine, but we don't know yet if it can infect other fish species. When we started the project, there was only one article published on this parasite. So for you to have an idea of the dimension of the emerging issue. So we wanted to tackle many aspects on this parasite, which is the pathogenic impact, how much is spread, how to detect it, how is it transmitted. And now I'm focusing on one of the other questions, which are the risk factors for this transmission. That is what I'm gonna explain you now. So the challenge was to know where is it present and how it entered the farms. So we defined a strong sampling effort in this longitudinal study through a 3-year survey in which we sampled 8 farms along 2 production cycles in 2 countries and from different stages, from the egg to the harvest sites. And in total, we have analyzed almost 2,000 samples that have been checked by qPCR. And in some cases, we have double checked by histology. And all the samples that were taken at the fish farms were sent to the facilities of the Institute of Aquaculture Torre de la Sal at our lab for the analysis. So this has been the sampling schedule. And the critical control points of the production cycle were deciphered together with the fish farmer, either because the fish were having different type of water, open flow, recirculated, borehole, or because the fish were eating different things, or were handled in a different way, or were passed from different buildings, from hatchery, nursery, prefattening, or sea cages. So we check the stages that were fed only rotifers or rotifers plus Artemia, and they were moved to commercial pellets. And we also check, we analyze the rotifers and the Artemia by itself, not only the fish that eat them. We started, the fish that the alevins here are the fish that are seeded into the sea cages. Depending on the country and a particular facility, they can enter as small as 1.9 grams up to 17 grams. And when they are juvenile already in the sea cages, we sample when they were 4 months or 8 or 11 months in the sea cages. In the adult stage, we sample them where they were at the harvest point. So these are the results for the first country. All the squares that are in green are those stages that they were negative for the parasites, and all of them that are in red are those that were positive. And these are the prevalences that we found. First, the suns here means the time of the year the fish are entering into the sea cages, early in the spring or the summer in this country. And as you can see, we have prevalence of infection is very variable, and it was especially critical in this point that fish were 100% infected, the samples that we took from here. And in some cases, we double check by histology if these fish were really infected, that we could see the visible stages. Probably you don't see anything in this picture, but Enterospora nucleophila is over there. So you can have an idea how small is this. It's the size a bit more than a normal nucleus in the intestine. In the second country, we have again this picture that they are free in these stages, but then they start getting infected very soon until they get all infected while they are in the sea cages. The fish were entered either in winter or in summer, and these are the prevalences that we detected in all these cases. As you can see, also the numbers are quite variable depending on the sites. So which are the epidemiological consequences of these findings? So the first one, all the ones that are in green are the free of parasites, and the ones in red are the positive for the parasite, is that fish are negative in both countries in all the periods and sample facilities from the egg to the fried state just after weaning, including the live prey they were fed during this time, no matter what type of water rearing system was used, either flow through or borehole. The second consequence is that the first positive cases were detected either when entering or when leaving the nursery. And the smallest fish harboring the parasite weighed 0.9 grams, very, very small. The third consequence is that both countries entered fish positives for the microsporidium at the cages, but with very variable prevalence of infection. And at 8 months in sea cages, all farms were positive for the parasite, even those that entered negative for the parasite. All the sea cages, farms, locations, production periods, and countries therefore tested positive in one of other moment of the sampling. And there is a decreasing trend with age, as we can see, but still positives are found at the harvest size, like we have in here. Fish that enter the sea cages with high infection levels, like those ones that have 100% of prevalence, perform really worse than those that entered without infection. We can see here the specific growth rate of infected stocks, the red ones, in comparison to the stocks that enter free of the parasite, is really much worse, at 40.9% worse. Concerning the difference in the timing of entrance in the sea cages, we didn't find any clear difference between entering the stocks in winter or summer. So in conclusion, the take-home message of all this epidemiological is that apparently there is no vertical transmission, since we never found in the egg and the subsequent in stages, though we didn't survey broodstock. Live feed seems not to be involved in the transmission, but is the water the source of the infection. And apparently some filtration procedures reduce the risk of transmission, because those nurseries that were using borehole have less prevalence than that was open flow directly from the sea. Fish can get infected as small as 0.1 grams up to the harvest size. And fish are seated in the sea cages already infected. And those that enter already infected perform worse than those that enter free of the parasite. And finally, we have found that the qPCR is a very efficient way of detecting the parasite. This is a qPCR that was developed in our group. You will hear later today about this. To detect the parasite, much is possible to do it than by histology. So we can say that we have filled the gap that we have at the beginning of the project with only one article. Probably we'll have 3 or 4 more in the coming months. And finally, I would like to thank all the fish pathology group. You have here the people, especially our technician Raquel, that looks like that after analyzing almost 2,000 samples. And this was also possible because we have an automatic robot for handling the samples that has made our life easier. Thank you. This is all.
Thank you very much, Ariadna, for a very nice presentation.